So I'm going to do problems number 21 and problem 24, and you should be able to complete the rest of 21 through 26 on your own. So starting out with 21 through 23, this says to calculate each percent using a z-score table. And then it gives us some information about the problem. The weights of bags of chips are normally distributed with a mean of 31 grams and a standard deviation of 4 grams. So before I even get to that question, I just want to kind of imagine what this looks like. They've given us enough information that I can kind of sketch this out. We've got weights of bags of chips. We know they're normally distributed, right? So bags of chips, they've collected a lot of data about bags of chips, and the weights are normally distributed, and the mean right there in the middle is 31 grams, right? So I'm going to write just 31, and then down here I'll say weight in grams, right? We're talking about bags of chips. And then the standard deviation is 4 grams. So if I go up by 4, then at 35, and down by 4, 27, up by another 4, we're at 39, down by another 4, 23, and then down here, right, where almost all of the data is, we've got almost all the data between 3 standard deviations at 43 and 29, right? So almost all bags of chips weigh between 29 grams and 43 grams, right? Okay, so this gives me just an idea of what I'm looking at. Now, let's go on to 21. It says calculate the percent of bags that weigh more than 33 grams. So I'm supposed to be using a z-score table to calculate this percent. So calculate the percent of bags that weigh more than 33 grams. Now 33 is right here. And I want to know when it weighs more. Okay, so 33 isn't an exact standard deviation, so I can't use the empirical rule. So this is where I need to use my z-score. I need to know how many standard deviations is 33 away. It's not quite 1 standard deviation, right? It's not quite 1 standard deviation away. In fact, I shouldn't have put it right there. I should have put it in the middle because it's exactly between there, right? So how many standard deviations is it away, right? 33, how many standard deviations is it away from 31? Well, if we take 33 minus 31, that's how far it is away, right? So it's 2 away from 31. But how many standard deviations is that? Well, 1 standard deviation is 4, so we need to divide that by 1 standard deviation to figure out how many standard deviations. It's 0.5. So it's 0.5 standard deviations away, right? And this is what we call the z-score, the number of standard deviations away. So 33 is 0.5 standard deviations away, and now we just need to look at that z-score chart. And we go down and we find 0.5. Now the only thing is it 0.50, 0.51, 0.52? Well, we know that 0.5 is the same thing as 0.50. So we go to 0.50. So this is 0.5. This is 0, right? And it's 69.15%, right? Because you move that. So 69.15%. But the problem is that z-score chart, it gives you what's beneath. It gives you beneath. We want to know how much more. But that's easy, because if down here is 69.15, then we just need to subtract from 100 to figure out what this side is. So 100 minus 69.15. So this is less, so more is 30.85%. That's how much is more than 33 grams. All right, so number 24, we've got similar kind of problem, right? This, I will say, this says determine each percent using a graphing calculator. We'll just keep using the z-score, okay? That's the main thing that we have. So the systolic blood pressure for women is normally distributed with a mean of 120 milligram. I actually do not know what that unit is. So a mean of 120 and a standard deviation of 12. So tomorrow when you guys come into class, you guys will have to tell me what that is and educate me. Okay, so systolic blood pressure. We've got a mean of 120, right? A standard deviation of 12. So again, I like to kind of draw it out just to kind of see what I'm looking at. So standard deviation of 12. So this would be 132. This would be 108. This would be 144. Take away 2. So this would be 96. This would be 156. And this would be 84, right? So we're going up by 12 and 12 and 12 and 12 and 12, right? So that's what this looks like. But now we want to determine the percent of women with a systolic blood pressure in between 125, that's kind of right in here, right? 125 and 140. So again, that doesn't fall on any nice even. If only it fell on the standard deviations, we could use the empirical rule, but we can't. So what we need to do is, we've got to have a strategy. We need to find the z-score for everything that falls. We need to find the z-scores. We need to find out what percent falls beneath 125. We need to find out what percent falls beneath 140. And then our strategy, then we can subtract to find the percent that falls between. So that's our strategy. Our problem-solving strategy. Find percent beneath here using z-scores, percent beneath here using z-scores, and subtract, okay? So, 1, remember to find the z-score. How many standard deviations is 125 away from 120? So, well, do this to find out how far it is away. It's 5 away, so how many standard deviations is that? Divide by 1 standard deviation, right? So 5/12, or if you want to do that in percent, this is 0.417, or actually we're using, so 0.42, right? You're rounding. 0.42, rounding to the nearest hundredth for the z-score chart, right? So now we want to find out the percent, so we go to our z-score chart. 0.42 is 0.6628. So 66.28% fall beneath 125, right? Now we just need to do the same thing again for 140. How much fall beneath 140? Well, how many standard deviations away is 140? Well, 140 minus 120 equals 20, but how many standard deviations is that? Divide by 12, right? So 20 divided by 12 is 1 point, and for z-score chart, we rounded the hundredths, 67. So 1.67, so 140 is 1.67 standard deviations away. So we go down to our chart to 1.6. We go all the way, you can hardly see this, but you go all the way over 1.6, all the way over to 1.67, right down here. So 0.9525, 95.25%. So 95.25% fall below 140. So from here to here, 66.28, from here to here, 95.25. So if we subtract those two, then we get 28.97. So 28.97% fall between these two. That's kind of what's left in there. So 28.97% fall right in this area. All right, so you do the rest, 22, 23, 25, and 26.